Hello. In the last video I have shown you how to send a validation report to the DBP platform. Now I will demonstrate the final step on how to validate a DBP project as a municipality and make a final decision on the application. As municipality, my starting point on the CHEK platform is the project overview of BIM server validation, developed by SIPE software. As soon as an applicant submits a validation report from a software solution authorized by my municipality for compliance checking, such as Map for checks with respect to the geospatial context, the DBP project will be listed in this project overview. The first step required is to assign a municipal officer as reviewer to the new project we just received from an applicant. Second, we need to choose one of the defined tags to connect the DBP project with the associated data module of Map to add geospatial context automatically on demand. Now we are already prepared to validate the project and will move to Map for the review process of geospatial checks. I will use the CHEK plugin to establish connection to BIM server validation. If you are not yet logged in, you first need to go through the authentication process using your BIM Server Center credentials. Then we connect with the CHEK Municipality Validation account. In the CHEK plugin window, I will find the signed IFC file that was submitted for validation. First I will do a visual assessment if the proposed design blends in well with the surrounding. I could also perform some manual analysis on shadow casting, or view shed analysis. After that I will inspect the semantic models as output of the BIM to geo conversion to be aware of any inaccuracies or other data issues that might have been introduced during data conversion. The conversion process may be sensitive to inattentive geometric or semantic modeling practice, so checking the result is essential, as the geospatial compliance checking process works exclusively with this converted data as a basis. Looking closely at the LOD0 that represents the building's footprint, stories, and floor plan, I recognize level 4 is lacking the encompassing geometry of the building story. I will keep this in mind for validation of the checks. Let's move on to the review of checking results. At first sight, it looks quite fine. What catches my attention though is the result marked as to review. I will need to inspect it in detail for a final decision on the situation. Therefore, I open the result details from the overflow menu next to the check name. The demanded value defined by the regulation is to keep at least a distance of 3 meters to the plot boundary, while the project still retains a buffer of 16 centimeters to this constraint at the point of least clearance. However, the specified tolerance range, which we have set to 20 centimeters for this check in our municipality, has triggered a request for manual review. Tolerances are defined by each municipality on configuration, depending on the geometric accuracy of their base data. At this location, my decision is in favor of the project, which seems to be just fine here. Knowing on the potential issue from the conversion process, I will have a closer look on the buildability index checks even though they seem to fully comply with the regulation. It becomes apparent that one story had indeed a conversion issue and is not present in the checked result. However, the checking engine seems to be robust in this regard and has combined the volume of that story with the one below. With a value of about double the one from the lower story, the calculation is in the expected range. Great. However, I recognized quite some overestimate with this setting of the checking process. Eventually the approximations taken by the default checking method are a little too broad for this specific design. So in this case we have an alternative configuration option that we can use at own discretion if better suited to the situation that might approximate the volume for this individual design more accurately. I will choose the option to show the check's default configuration parameters for this rule. Currently it's set to story-based volume, which multiplies the story's area by its height. I will unlock the configuration settings to temporarily overwrite the defaults and choose room-based volume instead. This one does not rely on the story's geometry but on the actual room volumes. Since this might underestimate the total built volume as defined by the regulation slightly, I will increase the tolerance a bit to be notified earlier for a manual review, if the calculated index is about to approach the limit. The current implementation of the Open API developed in CHEK limits the action to run checks to the applicant unfortunately. I am therefore also assigned with access rights to the designer's project space on BIM Server Center and need to rerun the check with the updated setting from that account. This result represents the project better at first sight. But the calculated value is unexpectedly much higher than before. I notice that there are some overarching geometries included in the calculation that do not represent rooms. We might have some inaccuracies in the model that introduce these issues during conversion that this setting change also could not overcome. Thus, I reset the settings to its default and return to the municipality view. The second buildability index check based on the gross area of the building is based on the same type of check, but is using the story-based area as input parameter instead. Here a proper story geometry is crucial to have a correct calculation. With the known issue, I cannot properly assess if the building meets the requirements. Actually, the designer should have noted that during pre-checking. I will return the design due to these shortcomings in order to fix the potential modeling issue and assure this can be properly checked by the software to rely on an objective result. I finally also check the other past checks to have an overall picture and to be able to give complete feedback. The height check visualizes the constraint limit, which is clearly higher than the design. No issues here. Also for the road distance. No road surfaces were found at the defined minimum distance from the building, which means that all road sections are further away. To prove, the closest street element is shown, with a distance of 4.82 meters, which is higher than the required value. So no concerns here either. However, due to the identified deficiencies, I must initially reject the project. I will document the shortcomings and send the applicant a written statement directly via the platform. This has been the last video of this video series. The VC Map CHEK plugin has been developed as prototype for geospatial compliance checking in the scope of the CHEK project by Virtual City Systems. For more information on Virtual City Systems, please visit our website at www.vc.systems. Thanks for watching.